starting to work with statistics, it's very quickly that you recognize that there are many vocabulary words that probably aren't in your everyday vocabulary, and then also a lot of symbols that you're not used to having a particular meaning tagged to them. And so it's really important to actively work at understanding the vocabulary words and what they mean in a statistical setting, as well as practice with the symbols that are commonly used in statistics, so that when you see the symbol, what it represents comes to mind, and when you think of a concept that has a symbol that would represent it, you know which symbol to use. This video is going to focus mainly on the vocabulary of a statistics, an introductory statistics course. I also have a video that goes over the symbols commonly used in statistics, and I'll put a link to that video in the description of this one. Again, it's very important that you get these vocabulary words and symbols down early in the process, so that as they're used more frequently in your problems as you go through the work, they will have a meaning and it won't slow you down when you need to actually process what it is that you need to do. So let's look at the vocabulary words and then some examples of how we identify them. So first, statistics. Statistics is one of those words that has a lot of different meanings, and it really depends on what context you're using it in. So if I talk about I'm taking a statistics course, or I am looking at the content of statistics, statistics in that setting is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or to answer questions. It is also important to give a measure of confidence in any particular conclusions that you give. And you'll find that later on when working with the inferential statistics. Now, the next thing is population. So a population is an entire group to be studied. Maybe we're interested in finding the count of the different species of fish that are in a lake. So if I'm looking at that, then it would be all the fish in the lake that we're talking about. Now, a sample is a subset of the population. And in most settings, we don't have the population, and we don't have really access to the population. We wouldn't dredge the lake to look at all of the fish, because then that would be pointless. We would ruin the ecological balance of the lake, and we would also kill all the fish. So we can't do that. But if we get a sample and we sample the situation appropriately, we can try to use information from that sample to give us a background to be able to make some sort of judgments or estimates or predictions about the population based on the information we gather from the sample. Now, if they say we have a parameter is a numerical summary of the population. So you can kind of, as a memory device, think, well, the P's go together. So when I'm talking about a numerical summary of the population, it's a parameter, and parameter starts with P and population starts with P. And a statistic, so again, we're using this word statistic, but in an entirely different context than when we used it earlier. Here, a statistic is a numerical summary of a sample. So what's also nice is that the S's go together, that a statistic is a numerical summary of a sample. Now, there's two kind of core content areas within the idea of statistics. One is descriptive statistics. And when we talk about descriptive statistics, you want to think a little bit of that root word describe. So descriptive statistics is when you're organizing, collecting, and summarizing data. So that is the part where we've got all of these either names of things, if we're talking about the names of the types of fish, or if we have measurement sorts of things, like when we talk about maybe the length of the fish. But we've gathered all of that information, and we need to organize it somehow or summarize it somehow so that it gets meaning when we present it. Inferential statistics uses the methods that take a result from the sample and extends that to the population and gives a measure of reliability when we do take information from the sample and try to extend that to the population. Now, most generally, you'll start out with descriptive statistics and learn a lot about how you collect, organize, summarize data, and then that will help us get a visualization of a distribution. And then we'll look at statistical methods to do the inferential statistics in a later portion of the course. So next up, what we're going to do is look at some more vocabulary. Now, when we're looking at statistics and setting up a process of statistics, one of the first things we need to do is to identify whatever our research objective is for the process that we're setting up. So you really want to identify that before you do any other work within the research project. Next, after you identify what your research objective is, you need to collect the data to address the question from step one. Now, collecting this data, there's a lot of different ways that we can organize the way we're going to collect a sample from a population. And the important thing to remember is we want to try to get a sample of the population that is best representative of the population that we can. And so depending on the situation that we're dealing with, this can take on a few different ways that we would need to go about that. Later on in this video, we're going to talk about sampling techniques, just a few of them. But the important thing is you would need to be very, very careful that you're not just getting a sampling from part of the population that would really sway what your then inferential statistics would represent about a population that might not be at all true about it. So collecting the data would be in our sampling techniques idea. Now, describe the data. Describe the data means that we're going to do a part of our descriptive statistics, whether it's make a table, a stem and leaf diagram, a frequency histogram, any of those sorts of bar charts, organizational structures, that sort of thing, so that we can get a visualization of the distribution that would help us determine what techniques we would need to use in the inferential statistics. And then finally, perform the inferential statistics using the methods appropriate for answering the research objective that also goes along with the distribution type that we're working with. And we would always want to give a measurement of our confidence of our results. Now, when we're looking at the data and collecting it, the random variable that we are focusing our attention on could either be qualitative or quantitative. Now, qualitative data is something that has a characteristic or an attribute. Like I would be looking at the fish to see if the fish are crappies or northerns or largemouth bass, that sort of thing. That would be a characteristic of them. I might be looking at politicians and seeing if they're Democrats or Republicans or independents. A characteristic is then what we would do if it's a qualitative aspect that we're interested in researching from our research objective. So that's qualitative data. And you can look at the root words of it: qualitative, quality, an attribute of it, whether a car is blue or white or silver or any of those sorts of things. Other types of data that we could have is quantitative. So you can kind of think of this root word being your quantity. So quantitative data would be a measurement like on the fish, measuring the weight of the fish or the length of the fish, or looking at somebody's height, or looking at their weight, or looking at any sorts of things that have a numerical measure that means something. Now, it doesn't mean that all numbers are going to be quantitative variables. If I have a number on a sports jersey, that's just identifying that player. It's not saying anything that's a measurement that's meaningful about that player. So the main thing that you want to think of with quantitative, it has to be a numerical measure of the individual, a measure of them. Now within the quantitative variables, the ones that are a numerical measure, these could either be discrete or they could be continuous. So you've got your data, and it's either qualitative, which is an attribute, or it's quantitative, which is a numerical measure. Under the quantitative, it's either discrete or it's continuous. So you can kind of like think about it broken down that way. Now discrete data is something that's countable. Like I can count the number of eggs in a robin's nest. I can count the number of puppies in a litter of puppies. I can count the number of goals scored in a game. I can count the number or the amount of money that I have in my pocket or that I paid for in terms of paying for gasoline or whatever the case is. So being countable, you want to think, can you put that out on a table and go 1, 2, 3, 4, 5, etc. Now it may be something that is a sequence that goes forever, but it would still be countable one at a time. Continuous is a random variable that flows from one value to the next, and you couldn't really put it out on the table and count it. We might sometimes approximate it at specific stops, but really the entity of a continuous quantitative data value is something that would flow. So your height is continuous. You have a transition from the shorter heights to going to the higher heights. We round them off at different increments, but there's actually a smooth continuum with it. So think of that. Think about it as a smooth continuum. The amount of liquid, like volume of liquid, amount of Mountain Dew in a pop can, that's continuous. I can't pour the pop can out on a table and go 1, 2, 3, 4, 5. So it's not discrete. It's continuous. If you look at somebody's weight or the weight of the fish, that again is something continuous. So those are vocabularies that go along with the type of data that is quantitative. Let's take a few moments to look at some different examples about identifying the usage of these newly learned vocabulary words. So here it says, determine if the given value is a parameter or a statistic. So remember, a parameter is a numerical summary about the population, and a statistic is a numerical summary about the sample. So in the first one it says, of the 47 Panera customers sampled, the average amount spent was $15.36. Well, this numerical summary of this average amount spent was $15.36 was from the 47 Panera customers that were sampled. So that's a numerical summary about a sample, so it's a statistic. The next one, of the 15 students sampled, 10 of them were freshmen. So here, again, I am giving a numerical summary about the 15 students that were sampled. So again, it is about a sample, so it is a statistic. The third part of this is, in the most recent census, the average number in a household is 2.99. Well, as you know, the census is something that takes the measurements of the entire population. So when they do a census, they work very diligently at making sure they gather information from the entire population. So this is a numerical summary of the population, so this is a parameter. Here's another example of just identifying the appropriate vocabulary word for the different situation. So here it says categorize it as qualitative. Qualitative, look at that root word, means a quality or an attribute. Or quantitative. Remember, quantitative for the root word is quantity, so that is something that has numerical measure. So the first one is the color of the car you drive. Well, the color of your car you drive is an attribute about your car. So that is qualitative. The make of the car you drive, again, that's an attribute or characteristic of your car. So again, that is qualitative. The age of your car. So how old your car is, that's a numerical measurement about your car. So that is quantitative. And then the amount of gasoline in your gas tank. Again, it's something that has a numerical measurement that goes with it. So again, that's quantitative. So hopefully that gives you a little bit more of an understanding of identifying the types of the data if it asks you to categorize as qualitative or quantitative. Let's now look at how to identify the difference between our work with our continuous or discrete random variables. So here it says determine if the quantitative variable, so again, we have our random variables, they're either qualitative or quantitative. But within the quantitative part, those quantitative variables can be either discrete or continuous. So we're looking at the quantitative values and we want to know whether they're continuous or discrete. So the first thing is the number of classes that you're currently enrolled in. So when you think about the number of classes that you're currently enrolled in, you can count, like on your schedule, how many classes you're enrolled in. So this is countable, so that's discrete. Now the next one is the time you spent on the internet yesterday. So time is a continuum. When you think about time passing, we measure it with approximated values, but it is a smooth transition between times. We don't like time jump. So when I think about the time I spent on the internet yesterday, that would be a continuous random variable. The next is the amount of gasoline in your gas tank. Well, the amount of gasoline in your gas tank is volume. You can't like dump the gasoline out and then count it. It is a continuous random variable. And then the distance you traveled yesterday, distance again. When you travel a distance, you have to go through the smooth transition from start to finish as you go. And so that again is another idea that is continuous. Yes, we might round it and say, hey, I traveled 100 miles yesterday, but really it was a smooth transition between the different values and it has a non-countable aspect to it. So those are some examples of identifying the difference between the discrete random variable and the continuous random variable. Next up are the levels of measurement. Now with the levels of measurement, these are the levels of the variables that we are doing our measurements for. So the first one is a nominal level. So if I'm taking a sample and I'm looking at a variable that is a name, a label, or a category, then that's the nominal level of measurement. So with the fish, that would be like if it were a crappie or a northern or a bluegill. With the car colors, that would be if it were blue or white or red or silver. Or even the make of the car, any of those sorts of things, that would be your nominal level of measurement. And that's the lowest level of measurement that we have. Now the ordinal level is when you have a naming or some sort of symbolism to it, and not only is it a naming, but it also has a way that you can put it in order. So ordinal, think of order for its root word. So if the naming allows me to put it in order, then it would be ordinal instead of nominal. For example, if I have a type of fishing reel and it's different levels of, or the different models of the fishing reel, but it's like good, better, and best. So I know that we've got the good, and then the better's better than the good, and the best is better than both the better and the good. So there's an ordering that it has. If I think of class ranking, whether someone is first in their class, second in their class, third in the class, that's ordinal. I know that that's the ranking for them. I don't know how far apart their GPAs were. I just know the order of it. So that would be your ordinal level. Now, interval level, it has the same aspects of the ordinal level, except that the differences do make sense when you're subtracting them. But it doesn't have an absolute zero, so that the ratios don't make sense, but the differences make sense when you're doing an interval level. So with these, you're talking about things such as temperature in degrees Fahrenheit or degrees Celsius. Those would both be examples of your interval level, because you can go below zero with your Fahrenheit. When we're in the winter time, we sometimes see that it's 15 degrees below zero. So if you have a measurement where differences make sense, but it has an entity that can go below zero, that's how you know it's an interval level. If you talk about also like the calendar year, like 1965, 2010, well, the calendar year has AD and BC, so it can go below. There's no like absolute zero starting point, so that would also be an interval level. Now for ratio level, the highest level of measurement we have for our random variable, that's where ratios have meaning, and there is an absolute zero. So with that, there is a temperature measurement that does have an absolute zero, where it means no heat, and that's in Kelvin in your science classes. If we look at time that we have to wait for a table at a restaurant, there's a point where you say, okay, we're going to start waiting for our restaurant now. So there's a zero start, and then from there you're measuring the time. So that would be another one that would be with the ratio level. If you're looking at maybe finishing time for people at a race, you know, you've got that start in which they started running the race, and then when they finish it, it's stopped with a stopwatch. So that again would be a level that would be the ratio. Now with these, most typically, the two that are the easiest to get confused are the interval and the ratio levels of measurement. So just make sure that if you're talking about some measurement that can go below zero in whatever setting that it's in, then that's going to be interval instead of ratio. But if you have something that has a zero start to it and then it's measured, then that's going to be your ratio. And we're talking about the statistical process, and one of the steps in there was collecting the data. I spoke about our sampling techniques. Now there are a lot more out there, and there are a lot of other ways to organize, but here are just a few that are very common sampling techniques. Now the first one is a simple random sampling. So for a simple random sampling, every possible sample of size small case n. So small case n in statistics represents how many you have in your sample. And every possible sample of size small case n has an equally likely chance of being selected if you've done the simple random sampling. Often what we do is we take our population, if we have an idea of it or have a way that we can at least assign numbers to it, we make what's called a frame. So that's the list of everything that we're interested in sampling from. And then we put numerical values associated with each of those. And then we use either a random number generator, a random number table, even if you pulled slips of paper out of the hat, something that would give just the chance happening with it of selecting items from that population to be in your sample, then that's your simple random sampling. Now with this, I want you to understand that you can't just look for the word random and then say, hey, that's simple random sampling, because there's other places within these other sampling techniques where an idea of random sampling within a sub-part of it occurs. And so you really want to look at, this is global, the entire population stays as a huge big group, and you're randomly selecting so many out of that population for your simple random sampling. Now next up is stratified sampling. So with stratified sampling, you identify some commonalities of groups. Maybe you're looking at a school district and you're looking at freshmen, sophomores, juniors, seniors. So with that, you would separate the population of students into these non-overlapping groups of your freshmen, sophomores, juniors, and seniors. And these are called strata. Now, with the stratified, once you have them broken up into those non-overlapping groups, you randomly select so many out of each of the groups. So that's your stratified sampling. Next up is cluster sampling. With cluster sampling, you're looking at separating the population into groups. A lot of times it's demographically. Maybe you do the school districts throughout the state of Illinois, or maybe voting districts or whatever that you have where you separate it into the groups. Now you're going to randomly select a few groups out of all of the groups. So you've got all of these groups, and you randomly select a few groups. And then once you have the groups that were randomly selected, you gather the information off of all of the individuals within those selected groups. So these two, the stratified and the cluster, are the ones that are the easiest to get confused. We're breaking them both, taking the population and breaking them up into groups. The difference that you have to look for is in stratified, you're sampling some out of every group, and with cluster, you're grabbing a few groups but then sampling all of the individuals within those selected groups. Now the next one is systematic sampling. With systematic sampling, we select every kth individual from the population. So you've got it in a line. However you can set that up. Maybe it's with people waiting to go into a movie theater or waiting to go into a store or whatever. So you have them in the line where it's first, second, third, fourth, fifth, sixth, etc. And you first are going to randomly select a number between 1 and k, and then that's your starting one, and then you do every kth individual in the line after that. Now there is a little bit of setup with the systematic sampling. So what you do to start with is you try to get an estimation of your population size, and that's capital N. Once you have an approximate value of your population size, then you want to think, well, how many do I want in my sample? That's your small case N. So determine that. Now take your population size and divide it by how many you want in your sample. And most generally that's going to be a decimal. It's not going to be a really nice evenly divided out value. So you're going to take that and you're going to round down. So if you get a number, for example, that is maybe 15.98 even, I'm going to go to 15. So you round down with this when you find your k value. So that's your k value. So then it would be every 15th in the line. But you want to randomly select a number between 1 and 15, whether you use a random number generator on your calculator, a random number table, or whatever. So you would count into that random value that's picked between 1 and 15, and then after that, do every 15th person or individual after that in your sample. So you've got a system to it, so that's systematic. And then the last one we talk about in this particular setup of the techniques that we're covering is convenience. And convenience is exactly what it says. You just sample whatever is the easiest to get. Now that's the one that's probably going to not give you very valid information, because it's very rare that you're going to get a good representation of a population based on a convenience sample. You're better off with these other ones. But if it's something that doesn't have as much consequence to it, then sometimes those are the types of samples that are taken. So now let's practice if we can identify the sampling techniques that are used in each of these settings. So here it says a tax auditor is picking tax returns to audit. Identify the sampling techniques that are used. And sometimes they'll even give you prompts to say whether you to pick the sampling techniques out of the choices of simple random, stratified, cluster, systematic, or convenience, or the simple random. So here it says select every 50th tax return. So if I have them where they're stacked up in a pile and I randomly start and then go in and I got the 50th one and then the 100th one and then the 150th one, etc. Every 50th tax return as I'm going through the list, that's systematic. Next, it says divide the tax returns by gross income. So I'm taking the tax returns and I'm putting the piles by gross income and then sample from each group. So if I've divided it up into non-overlapping groups and I'm sampling from each group, that is stratified. Next, number the tax returns and use a random number generator to select 15 returns. So here you've not subdivided them into any subgroups or anything like that, and you're using a random number generator, or it might even just say randomly select 15 returns out of the overall group. That is your simple random sampling. For number 4, it says divide the returns by zip code and sample all the returns in randomly selected zip codes. So I've made my piles of my